No, I mean, it's sometimes will. I think even this might actually be right. Let me think about it for a second. So it's not D, because it sometimes will, which might actually trick kids into thinking it's okay. So now the question is he right? And there's a way to find the minimum, and it's like negative. Well, let me just think. Isn't it? I was just trying to remember the formula to find the minimum or maximum, but I forgot it. But okay. I'm pretty sure it's B, that his answer is right in this case, but his strategy will not always produce the correct answer. Pretty sure just because I don't have any hard evidence, but because I forgot how to just calculate the minimum or maximum, but just from these tables and sketching it out, I'm just inferring that it's true that g of x does have a lower minimum. That's my reason.
Cool. Any other thoughts on that one?
No.
Okay.
Okay. Oh, I'm just realized, sorry.
Oh.
In an Algebra 2 class, John has been working on the following task. Find the average rate of change of f of x equals 3 times x minus 4 squared on the interval 2, 6. When discussing his answer, Sean explains that this one is 0 because the graph is symmetric. What is another problem you could give Sean to confirm your understanding of strategy? Okay, well, this question, one thing I'm thinking is, what do you mean his strategy?
Mm-hmm.
I'm not really sure what his strategy is. Just by... maybe he's just memorized that when a graph is symmetric, the rate of change is 0. I don't really know how he got that. He doesn't explain where he got that from. And so am I supposed to be... Okay. Right, so this is... Should I give him an example where it's not symmetric, and so he has to show me he can find the rate of change when the graph isn't symmetric? Is that what they're asking? That's my interpretation of what they are really wanting me to find. So, for example, A would not be symmetric on the interval 2, 6. So I'm thinking that A might be it. Okay. And then it also, this f function wouldn't be symmetric on the interval 4, 7. But it would be on C, this 4. So that would be symmetric. So if it's what I'm thinking, I wouldn't give C, because C, he could just sort of give me the same answer. Maybe he's memorized that. Oh, just kidding. That's a different function.
What were you just noticing?
Well, it's to the fourth power, so you got to read it carefully. Okay, let me think about that for a sec. Wait, just. Okay, but when it's cubed, I think it just looks like this. I think also if I gave him a linear or a cubic function, that would also give me new information on if he could find the rate of change of any type of function.
Mm-hmm.
In case he's just memorized that. So I think I would, if I'm understanding it correctly, I think D and E would make sense as functions to give him. Okay, so with that understanding, I think A, D, and E would make sense.
Okay.
And also B, because it's the same function but on a different interval where it's not symmetric.
Mm-hmm.
And my only question with C is if it's still symmetric on the interval.
Mm-hmm. So if it was, then would it be useful?
Well, I think so because it's a different type of function. Yeah.
So it sounds like the question stem is asking you about like confirming your understanding, and it sounds like the way you're understanding that is about kind of developing additional information about how Sean might think about different kinds of problems that are asking him for the average rate of change.
Yeah. So I think they want to know, my guess is like, can he find the average rate of change of any type of function?
Yeah.
That's what I'm trying to confirm, that he knows how to do.
Yeah. So what if the question stem had been asked a little differently? Like, what if it had said, what's another problem you could give Sean in order to further your understanding of his strategy?
Oh, like, understand more about like why he did this or how he did this?
Yeah, or maybe strategy is the wrong word. Like maybe, because like you said, his response is pretty sparse.
Yeah.
So maybe it's like, what's another problem you could give Sean to develop in order to develop your understanding of his thinking about average rates of change or something like that?
Yeah.
Would that be a better way of asking the question?
Yes, I think so.
How does what's the difference between selecting a problem to develop further understanding versus selecting a problem to confirm, your existing hypotheses about what he understands?
Yeah, I think confirm your understanding means like, does he actually get what's going on underneath? Or did he, for example, like just memorize this? Well, I guess if you're asking develop your understanding, that's more of like, I want to know like how he did this. But if it was like develop your understanding, I might ask like more follow questions to this particular problem.
Yeah.
Confirm is like, I'm going to give you another problem and see if you can still do it, even if it's different from the one I gave you.
Okay. Let me make sure I understand what you just said.
Yeah.
Confirming a strategy is, let me give you another problem and see what you can do with it.
Yeah.
And developing your understanding of Sean's thinking is more about like asking him questions to unpack or excavate what he meant by all of this.
Yeah.
Could you, instead of just asking him like a question in dialogue, couldn't you also, I'm just playing devil's advocate, couldn't you also give him a new task and see if he applies the same set of reasoning to it? Wouldn't that be a way to develop further understanding? Or is that something different?
Yeah, you could. I guess in general, if I'm trying to understand like how he did this, my first approach would be to dive deeper into this problem.
Yeah.
Before just giving him another one. Like what?
Yeah.
But I guess I'm a little confused. Like, what's the thing that they're like unsure about that they're trying to confirm? Like, is it just that they think he might have just memorized that when it's symmetric it's 0, but he doesn't actually know why, or like how to do when it's not symmetric? Then if that was the case, then I would just, you could go deeper by giving him just a different problem.
This is a really helpful conversation on this item.
Great.
This is a like kind of on the newer spectrum of items that we've developed, and we haven't got a lot of feedback on it. I think what we've learned, we have some other items that ask people about this same prompt about like trying to confirm and like the student strategy. Yeah. And I think one thing I'm learning is that this language of confirming is not. Doesn't have a shared, like a commonly shared meaning. Like lots of people have interpreted that phrase lots of different ways. The other thing I think I'm learning is that when we're writing these question stems and we're asking about a strategy, we need to be more specific about naming the strategy that we have in mind. Yeah. Like, so this, and again, this might not be the best example because his strategy is really opaque here. Like, it's not clear. It's not totally clear what he's doing. Right. So, but anyways, we might need to say something like confirm your understanding of Sean's strategy for using symmetry to find average rates of change or something like that. Yeah. But we need to be way more specific about naming the thing that we're asking people to think about. Yeah. Okay, that's really helpful. Great.
Oh, you're welcome. Great. Okay, students working on the following task. Write the following polynomial in the form A. Okay, blah, I had to read that. Okay. Yeah. 3x minus 2 times 2x plus 7. The students' work is shown below with an explanation of their strategy. Do you have to read this?
Up to you.
Okay. Oh God. Okay.
This is Do you have a visceral reaction?
Well, it's really procedural.
Yeah.
There's so many better ways to do this type of thing. Okay. Which of the following tests would give the teacher more information about the student's strategy? Oh, well, okay. My first thought, something like A, they couldn't just do this procedural thing where the top left always gets x squared, because it wouldn't be x squared. Okay. So I think if the strategy, is just like this really procedural way, then giving them something where the variables are different would probably just show the kid doesn't actually know what to do. Okay. And in this case, when it's in a different order, also, okay, these two.
So A and B are in.
Yeah. C wouldn't because it's the same format, so they would get the right answer. Yeah. And D also would give them the right answer, I believe. Okay, so definitely A and B.
So can you just say it like explicitly why for each one?
Okay, so A because it wouldn't be in the form ax squared plus bx plus c, the final answer. And it seems like the kid is just has just memorized that the top left number in the grid always gets x squared, which wouldn't be the case for A. And same with B, because the format is different, the constants first. Okay. C is in the same format as the problem, so he would get or she would get the same answer from their procedure. And D also would, but
Is there something about D that's...
Well, I'm just wondering if... Okay. The kid might not know to rewrite this like this and like which numbers go where. Especially, there's a lot of things the kid might not know. Like if there's a 1 here, for example, or that this should be like that. But I'm not sure that's... Like, what's the student's strategy that they're asking about? I think it's this thing that they talked about, which isn't...
Right.
Those things I just brought up about D. So I think D we also wouldn't want to use because it actually is in the same format if they just know how to write it out.
Right. And this does, like you're saying, it does give something additional that students have to be able to do, but giving this to a student wouldn't help you understand anything additional about what's happening up here. Yeah. Okay, cool. Okay. Good?
Yep.
Okay.
Consider the work shown below from Gabriel, a 9th grade student, along with the transcript of his explanation. Okay. Okay. For which of the following statements is there evidence? Okay, I think this is just D.
Okay.
Okay.
So talk me through each one.
Well, I'm not sure where he got these points, but it seems like he produced the point slope form. Mm-hmm. It's not like he was given this. How do you use the point slope form to find the equation of a line? Okay, well, I guess, no, he sort of did do A. Like, he used this form, now he found the equation of a line. Mm-hmm. Okay, fine. Let me come back to that one. Okay, so it's B. Okay, it's not true because my take is that we don't know if he could find the slope if it was negative. It seems like.
What about his strategy or the way that he did this?
I counted the length of my side, so he's not looking at the distance. Well, no, that is, I guess, just the distance, but it's not change of x and how x and y are changing. It's just the length. He's just thinking about it as like a triangle where these would always be positive because length is always positive.
And so why would that be a problem? I'm just playing dumb a little
bit. Yeah.
So why would that be a problem if the line had a negative slope?
Because then he might not get the right slope if he's just counting the length. Okay. Like it would be -6, but he would just count as 6.
Okay. Okay, so B is out for that reason.
Yeah.
Okay.
C, okay, well, I don't know if he did the coordinates correctly because I don't know where he got these points from. So those could be like the wrong points. Like maybe it should have. Well, I figured out where these 2 points were. Yeah, I don't know if those were supposed to be the points or they're supposed to be something else. Like, he plotted 10, 6 and -2, -4 correctly, but I don't have it. What if those weren't supposed to be the points?
What do you mean?
Well, first I figured out what these 2 points were. Oh, I get it. So this line was given to him.
Yes.
I thought it was like
Yes, that's right.
Oh, okay, fine.
So how did you? How were you thinking about it initially?
Okay, I thought it was like I thought he might have drawn this line. Well, first I figured out what these 2 points were, and then okay.
Yes, so you can assume the line was given to him.
Okay, maybe they should say that.
That's helpful.
Okay, because I thought maybe there was like some context, and I figured out what these 2 points were like from the story or whatever, and he plotted the points.
I gotcha. So if it had said like find the equation of the line given below, would that be enough to?
Oh no, I didn't even read that.
Okay,
I think that's actually totally fine. Find the equation.
Maybe we just need to make this a little bigger.
Yeah, sure.
Okay.
Or I should read the directions. Okay. Yeah. Okay, fine. Then I changed my answer. Okay. Sure.
So that makes C is in.
Yeah.
Okay.
Yeah. Right. He did that right.
Okay.
Okay. Wait. Did he do this right? Yeah. Okay. Now with D. Okay, well, one counterexample I'm thinking of is if he had tried to plug in these 2 negative values, would he have known to do like y + 4?
Sure.
But it seems like with the positive ones, he did substitute them correctly into the equation. So that's the evidence I have for that.
Okay.
How to use this? Oh, this is a typo. Gabriel knows how to use of points.
Yeah. How to use.
Yeah.
Yeah.
To find the equation of a line.
The question stem is asking for evidence.
Yeah.
What if the question stem had asked for clear evidence? Would that have changed how you decided on the options? It's kind of like a stronger ask.
Right. Yeah. Well, as long as it's not proof, because I would say like from one problem that you never have proof.
Sure, of course.
Yeah. So.
Or like strong evidence.
Is there strong evidence?
Yeah,
Yeah, strong evidence. Okay. Well, the thing I'm thinking is like, there's pretty good evidence, but it's not like super clear or super strong. Like, what if the 2 points had been negative? I'd be curious to see if he could do it, but
like with the ask as is, there, if you feel like there is some evidence for A and C and D.
Yeah, I do.
Okay.
Yeah.
But if it had been clear evidence, maybe there's not enough for A?
Well, yeah, I'm wondering if it had the word clear or strong, I might like overthink it. Like, maybe you're not asking, like, am I supposed to generalize? He could find it in all possible cases, like, or to assume that maybe he couldn't do it if it was negative, but that's just something I'm thinking of.
Yeah. Cool.
Yeah.
2 more.
Great.
You doing good?
Yeah.
Okay.
Great. Okay. Good. Okay.
You stretch?
I'm okay, but go for it. Roberto, a student in Mr. Booker's class, offers up the following definition of proportional. Roberto, X and Y are proportional if every time you add a number to X, you add the same number to Y. In response, Mr. Booker generates the following example in order to help Roberto revise his definition. Which mathematical rationale might have motivated Mr. Booker's example? Wait, let me just see. Okay, I don't think it's A, because this is, I think they would have shown something with a y-intercept other than 0.
Okay.
To show that it's linear but not proportional.
Okay.
This is both linear and proportional.
Yeah. This is the example that Booker generated.
Yes.
Yeah, okay.
So, also, I don't think that's not the misconception Roberto has.
About confusing
Yeah.
linear and proportional relationships.
Yeah, also, I'm wondering if Roberto, is he just thinking it's additive, or is he also thinking, is it, not only is it additive, but whatever the change in X is, the change in Y also is? Like, if they're both the same.
It seems unclear from what Roberto says, right?
It could be either of those. But I think B is important because this will show that it's not additive, it's multiplicative, and also that there'll be different things going on, like this is always times 3, and then this like times 5, whatever, all the different types of multiplicative relationships.
Okay, so B, like you just circled B, and then you kind of like sketched on the Booker's table about kind of all the different multiplicative relationships that exist. Okay.
Yep. Okay, this is also important because it sort of jumps around, like they're not quote unquote in order. Like they don't. It would just instantly disprove this because you're adding 3, but then you're adding 1 for the change in X, blah blah. So
So you're understanding this business of how the ordered pairs in the table are ordered to have to do with like the distance between the ordered pairs. Is that right?
Oh yeah. Oh, versus what's X and what's Y. Ordered as in like, I guess maybe they're also thinking of that order, like which value is first, or is it ordered like this way?
I was clarifying, like the second thing you just said. So like, it sounded like the way you were talking about it was attending to the differences between consecutive terms in the X column. Yeah. Versus like what you were saying about like maybe like the 4, 12 comes first, and then the something like that.
Right. Though also, I think one thing now I'm thinking of, it has the word ordered twice, but I think the question's using ordered in different senses.
Mm-hmm.
Is that correct?
Yeah, I agree with that.
Okay.
I can confirm that.
Okay, great, got it. Okay. Montessori wants to expose Roberto to a variety of examples in order to promote the development of more robust schema. Okay, I think D. It's not like D's not right, but that's not like the reason he's I don't think that's the rationale, because he should be addressing the misconception, not just like showing him different examples.
Yeah.
So I'm gonna say no.
Okay.
And again with E, it's not. I guess he'd want to get him to use precise language, but I think his first priority right now is just addressing the misconception.
Mm-hmm.
And I think it depends on their conversation around this table whether the language is precise or not.
Right.
Yeah, but this isn't about precise language.
Cool.
Okay, that's my answer.
Good.
Great.
Any other thoughts?
No.
Okay. Last one.
Yay. Okay.
Unless you want to go back and think some more about
maybe.
Hayden's strategy.
Okay, I'll think about it. Okay. In a class discussion concerning the range of absolute value functions, Ian, a ninth grader student, volunteers to give a strategy to find the range of the function. According to Ian, when we are finding the range of an absolute value function, we only need to focus on the second term, because it doesn't matter what you plug in. The stuff in the absolute value bars can never be smaller than 0, so we can just replace that with 0, and then the range will be whatever y value is on the outside to infinity. Like for this function, the range is 5 to infinity. Okay. Oh, you have the word clear. Okay. He understands what the range of a function is. It seems like it because he says will be whatever y values. It seems like he understands all the possible y values.
Okay. And you like even underlined like where in his explanation he's talking about y values.
Yeah, and he goes to infinity, so he knows that like we're trying to think of every possible
okay
y value.
Okay.
There's no evidence about interval notation because he's not writing. You don't see him write the range.
Yeah.
I think that's what they're asking. Okay. He does know how to find the range of this function. It seems like he knows what absolute value means because he says, it doesn't matter what you plug in, the stuff in the absolute value bars can never be smaller than 0. That's true.
Mm-hmm.
I'm just trying to think of...
So you kind of skipped over B.
Yeah, wait, I'm just trying to make sure that there's not... Like, his strategy will always work. Yeah. It will always work because this is... Oh, no. Okay, yeah. I think this will always work. Yeah, that's just the strategy.
You kind of like were you thinking about something?
Well, I was just trying to like just confirm that his strategy will work. I was just like running through different counterexamples in my head, but I believe this will just always work.
And you couldn't think of one that would like cause a strategy to fail or something like that?
Right, because this term, it's like the way you can transform it. Like, that's just like the vertical shift.
Mm-hmm.
So, and, right, even if this was negative, I was thinking like if this was negative, would his strategy still work? But it seems like it, because he says whatever that number is to infinity. So I think he would, if it was like -3, he would know it'd be like -3 to infinity.
Mm-hmm.
Wait, just give me one more minute, but I think.
Yeah, as much as you need.
Okay. Yeah. Okay. I stand by what I said.
Cool.
Is that it?
That's it.
Okay.
Do you want to think about Peyton?
Okay.
If you want.
Okay.
If you don't want, I'd be happy to unpack it with you.
Yeah. Oh, really? Okay. Yeah. I mean, will it be value for you for me to unpack it?
I mean, at this point, like I think, so I'll leave it entirely up to you. Because on the one hand, like you were talking about how this is content that you haven't really thought about or taught in a while, and so that's actually really useful for us to know that like some of these things, like knowing like the mathematics involved in teaching this really depends on having actually taught it.
Right. Which is, I think, I mean, my philosophy. Like, it's a larger problem of like math teachers in this country is that like you don't actually have to know that much math. Like, like it wasn't hard for me to like pass the state test, but like you sort of just deep dive into what you're teaching, and like you can really easily forget other stuff.
Right.
And like I'm not like a math major. A lot of people.
Yeah.
And I think that's a problem. I remember like in high school, one of my teachers couldn't. My homeroom teacher couldn't help me with my calculus homework because she didn't teach calculus, and I was like, "Well, you're a math teacher." Whatever. So I think that's a problem. So I'm a little embarrassed, but that's okay. But I would love to hear your thinking on this.
So Peyton's strategy will always produce a factorization of the form like x minus r1, x minus r2.
Yeah.
And if you expand that back out, you're going to get x squared
Oh,
plus
so
da-da-da-da-da.
there was no coefficient.
Yeah, and
okay.
so Peyton's strategy will work only when the polynomial under consideration has a quadratic coefficient
okay, that's
of 1.
what I was thinking. Yeah.
Yeah. You were totally in that right space. You were thinking about it over here.
Yeah. Right.
So his strategy will be okay here and here, but it falls apart on these other ones.
Wait, the whole thing about like was that?
I mean, so I would argue that whether or not it has complex roots doesn't matter.
Yeah.
So like for example, B, if you used Peyton's strategy, you would get x equals plus or minus 3i.
Yeah.
And then you can just plug that in and write x plus 3i, x minus 3i.
Yeah. Right.
Which is a valid factorization of x squared plus 9. Yeah.
I think some teachers might circle B though, because
many have.
Oh yeah, because of I.
Yeah.
Yeah.
Or they rule it out because they assume that Peyton doesn't have any understanding of of complex numbers.
Right.
But that's actually like not what we're asking.
Right.
So even though many people have ruled it out, we would argue actually that in fact it is a correct answer.
But I think what teachers are thinking is like the order that things are taught. So there's so many kids who know this but haven't learned that.
Right.
So that's probably what they're thinking.
Yeah.
Okay. Oh damn, I was close. Okay.
You were really close.
Yeah.
I was sitting there thinking like, if it was like a classroom right now, I'd be like, I would want to like offer you some encouragement.
Yeah. Okay, got it. All right, cool.
Thank you so much.
Yeah.
Are there any other items that you want to like go back and think on some more?
I'm good unless you have other questions about stuff.
No.
Oh, great. Okay, cool.
Thank you so much.
Yeah, this was fun.
I'm glad you enjoyed it.